Um, Hello everyone. Here in this session, I'm gonna talk about the striped logical volume. Why and when could be used. So, sometimes we may need more performance from our storage devices that exceeds its capabilities as specified in its specification datasheet for doing some specific tasks. But as we already know, the specification defined for any device cannot be changed or pushed beyond its limit. That's absolutely true. But wait, there is a way around this, especially for storage devices when used as group in striped logical volume. The case with which we can get much more performance than using it as a separated storage devices. In case of two disk setup, the striped logical volume, when properly configured, can double the input-output performance of the storage devices. And depending on the number of drives participating in a setup, we can push the input-output performance much further away beyond the limit of the standard separated usage. And so there is no need to pay a lot of money for buying new expensive technology to get the required capabilities and replacing your old hardware. Here in this session, I am going to show you how to nearly double the input-output performance of your hard drives when combining two of them in a volume group and let them works as single unit in a striped logical volume setup. So let's do it. We already have two extra hard drives in our system, 500 gigabyte each. Both have nearly the same capabilities and specifications, and we can use the hard disk parameter utility for checking that. First, we need to list the connected devices to find out the device names we're gonna work on. The ls block is a good utility for that. Okay, it's SDB and SDC. Now to get the information about SDB, we use the hard disk parameter utility with the I option for that. Hard disk parm I and device name device SDB. Okay. The logical and physical sector size 512 bytes. Cylinders, heads, sector per track 63, and the cache buffer size is 16 megabyte. Okay, and for SDBC, the same size, same sector size, cylinders, heads, sector per track, cache buffer size, it's nearly all the same. And it's nearly the same as device B. Okay. As you can see, it's nearly the same. The sector size, the cache size, the head cylinders. It's important for all these parameters to be the same on both drives. Otherwise, you won't get the expected result. Good. Let's now label these devices as GPT partition style, then create a partition of 100 gigabyte size on each drive. we can use the parted command for doing that. G parted, parted, select device SDB, make label GBT, yes, okay, make part, let be part 1, but here should be xt4, start 100,000, which means 100 gigabyte. Let's check. It's okay. And for the second drive, select device SDC, print, make label GBT, yes, make part, also part 1, ext4 1 and 100,000, print. Okay, now we can quit. Okay, let's now create an ext4 file system on both partition. Make fs type ext4. Before that, let's list block. Now we have SDB1 with 93.1 gigabyte and SDC1 93.1 gigabyte. Okay, file system, make fs type ext4 device SDB1. Okay, yes, okay, and C1, yes, okay, list log device, okay, list block device, the name fs type, okay, okay. To benchmark these drives, again we can use the hard disk parameter utility for that, to find out the read speed, and the dd command to get the write speed. But here I'm going to use the genome disk utility, or genome disks, since it's nice, much simpler, and graphically display the benchmark results on the screen. Okay, under utilities, disks, okay, this is SDB1, okay, start benchmark for sample size 10 megabyte. Start. So for 10 megabyte sample size, the average read rate is 96.6 megabyte per second. The average write speed is 82.1 megabyte per second, and the average access time is 8.54 millisecond. Okay, for 50 megabyte sample size, it takes time. Okay, now for 50 megabyte sample size, we have an average read rate 88.9 megabyte per second, and average write rate is 78.7 megabyte per second. The average access time is 8.54 millisecond, which is a little bit smaller from the 10 megabyte sample size. Okay, for the second drive, which is SDC1. Okay, start benchmark. Start. Okay, Okay, for 10 megabyte sample size, the average read rate is 87.3 megabyte per second, and the average write rate is 76 megabyte per second, and the average access time is 9.43 millisecond. Let's see the benchmark at 50 megabyte sample. Start. It will take a time, so we have to wait. So for 50 megabyte sample size, which represent a large file, the average read rate is 81.7 megabyte per second, and the average write rate is 78.3 megabyte per second. The access time is 9.42. Okay. Let's now create a striped logical volume, then benchmark it to see the difference. First, you need to unmount the devices if mounted. Then we use the PV create command to create physical volumes from these devices. Now create the volume group from the SDB1 and SDC1 partitions, and for simplicity I will name it my VG. Next, create a striped logical volume with name data, size 100 gigabyte from these two partitions, with stripe size 128 kilobyte from the myVG volume group. Okay, we can use the LV display command with the -m flag to get a detailed information about the logical volume we just created. Now we need to create ext4 file system for this logical volume with default 4 kilobyte block size, 32 kilobyte stride size. This because it's equal to the logical volume stripe size 128 kilobyte divided by the file system block size, which is 4 kilobyte, and 64 kilobyte stripe width. And the stripe width equal to the stride size multiplied by the number of disks or partitions used in the logical volume setup. Okay, to confirm the file system stride size and stripe width, we use the tune e2fs command. And to check the file system block size, Okay. Let's now benchmark this logical volume to get its average read and write speed. Again, we will use genome disk utility for that. For 10 megabyte sample, let's start benchmarking. And here's the average read rate is 156.2 megabyte per second, and the average write rate is 116.9 megabyte per second. The average access time is 8.29 millisecond. Okay, let's do it for 50 megabyte sample, and it will take time, so we have to wait until it finish up working. So for 50 megabyte sample size, the average read rate is 163.7 megabyte per second, and the average write rate is 123 megabyte per second. The average access time is 8.26 millisecond. And as you see here, we have nearly double speed in both read and write operation at large file size. Okay, let me now explain you why this is actually happened. First, we have had used the pvcreate command to initialize the partitions so that it can be recognized by the logical volume management, then could be used in creating a volume group. Next, we used the vgcreate command to create a volume group out of the physical volumes specified on the vgcreate command line. The command itself will divide each physical volume into a large number of small fixed size chunks called physical extents. The extent size can be defined by the volume group with this option. The default is 4 megabyte, which is good enough in our case, but all physical volume within the group have the same extent size. The logical volume which we have created out of the volume group, and depending on its size, will use a number of extents that are mapped to it by the volume group. And according to the logical volume type we are creating, the mapping process could be linear or striped, but since we chosen to create striped logical volume, the striped mapping will be used here. So the extents that are allocated to the logical volume are equally distributed among the physical volumes within the volume group that are used in the logical volume setup. But you can mention the devices clearly at the LV create command line. Actually, all the magic is done due to this mapping process. The extents on the physical volume are called physical extents or PE, while the extents on the logical volume called logical extents or LE. And when you use the LV create command, a mapping is done between the physical extents and the logical extents. With respect to the striped logical volume we have created here, and as you see in the picture, the LV create command have chopped the logical extent to number of stripes, each has 128 kilobyte. Then uses the round robin process to store the successive stripes on different physical volume during the write operation, which means parallel writing on all the drives participating in our setup. The read operation also done the same way in parallel from the different drive participating in this setup. That's why we got a nearly double speed in both read and write operation, provided that each drive should be attached to a different disk controller, which is the case with the SATA connectors on modern motherboards. Also, when creating the ext4 file system for the striped logical volume, you have to correctly calculate and pass the stride size and the stripe width to the makefs command that corresponds to the file system block size you chosen here. The stripe size and the number of hard disk or partitions used when creating the striped logical volume. The following equation should be used to calculate the stride size and the stripe width. The stride size equal to the logical volume stripe size divided by the file system block size, and the stripe width equal to the number of hard drive or partitions used in creating the striped logical volume multiplied by the stride size. So for 2 hard drive setup, 128 kilobyte stripe size and 4 kilobyte file system block size, we have a 32 kilobyte stride size and 64 kilobyte stripe width. And these values should be passed to the make file system command. Now for optimum performance, the file system should be created as follow: makefs-t ext4, because we are creating an ext4 file system, -b for the file system block size, 4096, which is the block size, the file system block size, -e stride equal to 32, comma stripe width equal to 64 kilobyte for the device /dev/myvg/data. Now you can mount this file system and use it with the applications that may need such performance, like high definition video recording or editing, playing, or something like that. You can mount the device as you mount any file system. Mount slash dev slash myvg slash data on some mount point slash mount slash data. Okay. And to let the file system automatically mounted at boot time, we need to get the UUID for this device using the block ID device name, which is slash dev slash myvg slash data. Then added the following line to the slash etc slash fstab file. Save and exit, and you are done. Okay, that's all. I hope that the discussion here helped shed some light on this important topic. Thank you for watching, and bye.